Let's continue the thought of ecosystem services, which basically means something we would like to value, non-market goods especially, like we talked about pollination and protection from pests, etc. There are, though, concepts that have been put around by people like Herman Daly, which talk about ecological economics. Is sustainability really separable from the environment, right? The idea was of Herman Daly, who wrote extensively, was that we generally think about sustainable development as an intersection of environmental concerns, economic aspirations, choices, intentions, and social nurturing of community. Whereas his idea is that actually society and economy live within the environment. So everything we do has to worry about environmental footprint and degradation and whatever we value, like sustainable natural and built environment, sustainable economic development, equitable social environment, and so on, have to fit uh, by design into these things. Okay, so here modeling economics and the Earth system science. The Earth system is good enough. So this is an example from here, which is a schematic illustration of the so-called DICE model, Dynamic Integrated Model of Climate and Economy, that Nordhaus uses in his work, Climate Casino and so on. So it worries about energy, labor, capital, and then the economic activities like production, GDP, abatement, consumption, investment, and also wants to add happiness as an indicator. There are even ideas about gross domestic product to be replaced by gross national happiness index, gross happiness index, I think, from Bhutan, for example. Sounds fancy, but they have tried it. So here moving towards happiness, here moving towards reducing carbon emissions, CO2 accumulation, and global warming, as well as reducing damage and feedback to economic production. Obviously here, climate is not a very explicit thing. It's an input in these terms of how these activities could lead to those. So those are considered kind of necessary simplifications, which leads to the concept of social cost of carbon. So it is the cost of each additional ton of CO2 put into the atmosphere in terms of various metrics. Why is it additional ton? Because there is always CO2 in the atmosphere, and we just need to figure out what the additional ton of CO2 is going to do in terms of crop yields, health outcomes, sea level rise, glacier melt, forest degradation, or whatever else you want to measure. So here is the social cost of carbon being estimated in US dollars per ton of CO2. Some regions have negative costs because they are sequestering net carbon, and then there is no information in some places, and then there is a varying range of social costs. For example, India here is in the $50 to $100 per ton of CO2. So this is a spatial distribution of median estimates of costs of social costs of carbon. What is CSCC? You look it up. Computed for reference case scenario from the IPCC process, the shared social pathways 2 and the representative concentration pathway 6.0, which we will see what it means. So there is a discount rate involved in there, and there are various other assumptions which I won't go into, like multiple models, damage function specification, which is a big kind of a knob or a uncertainty in these models. But you can see that the social cost of carbon is going to depend on Earth system models, because the impact of carbon, especially into the future, is going to be determined by Earth system feedback processes. So there is a close relation between the economics and natural Earth system science. Okay, so this is on global benefits of a decisive shift to low carbon economy when compared to business as usual, where we don't do anything, we keep using fossil fuels, driving, flying, deforesting, etc. And we are actually on a business as usual emission scenario right now because we are increasing atmospheric CO2 by about 4 ppm per year. Okay, so I'm showing this because actually direct economic benefits are estimated for these in terms of, let's say, avoid over 700 premature deaths from pollution. So that's the ecosystem services. Raise 2.8 trillion in carbon price revenues and fossil fuel subsidy savings to reinvest in public priorities. So it's revenue from carbon taxation kind of market-based policy, as it is referred to. Higher GDPs, generate additional low-carbon jobs, and female employment and labor participation. So you can see here how Earth system model inputs will go into economic calculations. So this is just the shared social pathways narratives. I won't go into details, but they worried about sustainability and various approaches to mitigation and adaptation, including regional rivalries, inequalities, and fossil fuel developments, and so on. And they combined with what are called representative concentration pathways, evolved with assumptions on economic development, GDP growth, renewable pathways, carbon capture and sequestration, bioenergy and carbon capture and sequestration, population growth, etc. And these numbers here, 2.6, 4.5, 6, and 8.5, refer to the net energy imbalance that will be produced by these pathways. So 2.6 corresponds to 2.6 watts per meter squared imbalance, which means Earth is trapping additional 2.6 watts per meter squared, which leads to about 2 degrees C warming. So this is a target which aims to keep us on the 2 degrees C emission target, and the others are obviously higher, as you can see. And the gray envelopes are basically the uncertainties or scenarios, multiple scenarios run by multiple models, in fact. But you can see that the emission here has to start dropping already by 2020 to reach the targets of keeping the additional forcing to 2.6 and the temperature target to 2.6. The resulting carbon emissions concentrations in the atmosphere are shown here, and these are typically aimed for the 2100 time horizon. Okay. So these are the global average surface temperatures expected from those. You can see the 2.6 is in this range that we want to stay in, preferentially with a certain probability. For example, this guarantees a 66% probability of staying below 2 degrees C, and this is essentially the business as usual scenario, which would bring us a warming of more than 4 or 5 degrees, which happened about 150,000 years ago in the Eemian, associated with the sea level rise of 5 to 8 meters, and so on. Okay, so these are the societal responses and policy context for the SSPs. The phase space goes over socio-economic challenges for mitigation and for adaptation. So you can choose low challenges for both mitigation and adaptation. Mitigation challenges dominate here, high challenges in both, and adaptation challenges dominate here. And here we are in the intermediate challenges. So each pathway then has to be mapped onto the resulting impacts and outcomes. So it's a bit tricky. Okay, so this has already gone for almost 10 minutes. I will stop this and finish the last two slides in a minute, but you get the sense of how IPCC, the Intergovernmental Panel on Climate Change, is trying to handle both the Earth system part, physical part with the RCPs, and the social science and the human dimension part with the SSPs. There are also now ocean pathways to managing marine ecosystems and so on being considered.